Good morning. It's Monday morning, February 6th. And believe it or not, this is the start of week 5. So we are moving along. We have as usual, some important topics to cover in class today. All of them are covered in the D2L material. So we're just going to cover them from a slightly different perspective. In particular, we're going to take a serious look at sliders for a couple of reasons. One is that sliders are going to come up in a whole bunch of your upcoming assignments. So that makes them an important topic. The other is that they're a very convenient user interface tool because you can't mess them up. What can you do with a slider other than to drag it from one end to the other? So it's good for that when applicable. Based on special request, we're going to look at sliders, both from the perspective of the simulator, the physical simulator, and also from the perspective of guizero. So you'll see that they're kind of the same, but different. But we'll look at both of them. There's also a section in D2L that we're going to cover that's important, and that's the issue of counters and accumulators. Those are both kind of fundamental tools in any programming language. They don't have anything necessarily to do with GUI programming versus console programming, but they're really important and you need to see how they work. And I've combined the two concepts into one program. But we're going to do the program 2 different times. The first time, we're just going to get it done. And the next time, we're going to try to make the program do as much user validation as we can. So that will make it a longer program. And will also let us look, I think we've seen while true already, but we're going to look at it again. And we're also going to see a structure called try-catch. So try-catch is a very powerful way of dealing with things that go wrong. And we want to take a good look at it and convince ourselves that it's not that hard to use and the value is there in using it. The other command we're going to look at from a couple of different perspectives that I think we've seen already, but we'll look at again is break. So break is a keyword in Python. Its brother or sister is continue. They're a little bit different. They are explained in D2L. We're just going to look at break. So that's what's on the agenda for today. I don't think we're going, well, I'm pretty sure, very sure we're not going to do any breakout stuff today because I don't have anything prepared. So let's try to give that a go on Wednesday. So before we get into the material, let's go back and look at the course and we'll see important announcements that I hope you've read. Help available from me, which is old news, through a website called You Can Book Me. So far, no takers, but the offer's out there. And we can see that February 12th, assignment 4 is due. So I've been talking about this for a week or two. It's it's the first substantial programming assignment that you've had. Now, we started with assignment 3, so we're not very far along, but it's substantial. It takes some time. I will say, and no one will listen, but I will say you need to start early. Don't start this on Saturday or Sunday. Start it now if you haven't already. You got something to submit it. You have a question, attach the no. You got a question, cut and paste your code into an email message and ask the question that way. Hey, I don't know what's going on here. Can you explain this error? Don't send me an email with code that says my program doesn't work. That's not a good enough question. It's not a question. Matter of fact, it's a statement. Just looking ahead, coming up the week after is assignment 5, temperature notification. we'll talk somewhat about that, about the concepts needed for that today. End of the month, February 26th, is something exciting. It's our first project. And projects are more difficult than assignments. Projects count more than the assignments do. So projects can't be blown off. If you promise not to tell anybody, you could probably blow off an assignment or two and still do okay in the class. There are only 3 projects. You can't blow them off and expect to do well. You could, if you do all your assignments and the final project and blow off one of the projects, one of the 3 projects, you probably would make it. Speaking of which, due the same day, February 26th, is the final project proposal. So the way the course is now structured, this is a big deal. It's the highest point value. It counts more than anything else, counts for 20% of your grade. So if you don't do the final project, which last semester many students didn't, if you don't do the final project, you're starting out with an 80. And that's okay, as long as everything else is submitted and has a very good grade on it. In other words, I don't think it's okay. I don't buy the line about, well, the final project is optional. I think I've already mentioned, and I'll mention it again, the 6 students who passed the class last semester all did a final project, and conversely, the others didn't. So we'll talk about that probably next week and discuss what we expect you to do in the final project and also what we expect you to do in the proposal, and how important starting early is. So that will be upcoming nagging about don't wait until the end. All right, so before we wander off into other things, are there any questions outstanding from the audience on assignment 4, which is due the end of this week on Sunday? Questions? So that means you've all, whoever's here, the camera is right under the, for the 6 of you who are here, you have no questions and you've got the thing well in hand. Wednesday, obviously, is the last chance in class to ask questions. But if you really have a question and you're not in class and you want an answer, send me an email or do a You Can Book Me. Okay, so what I'd like to do is I'd like to go review some code that we've worked on. And this is not it, although this is pretty darn interesting. It's not it. This is an example of something called turtle graphics, which is a different flavor of GUI than guizero is. But we're not going to work on that today, unless you'd like to. Incidentally, while we're here, turtle graphics is a viable GUI for doing a final project. So there are some students who have done their final project not using guizero, but using turtle graphics. And if that's something that interests you, we can talk. It is certainly viable. The one student who I remember doing it got a very strong A. He did a beautiful job with it. So let's do a little bit of review, kind of keep track. And let's start by going back to the simulator demo that we did already. So most of your assignments are written based on the physical simulator. And that's the way it is. So that's the way we're going to do them. So we could use this, or we could go back to our templates and use that. We don't need to start this from the beginning each time. We can start it from a template. And the template would include these imports, typically. A main function, this funny looking thing down here to run the main function, and and establishing a sensor object. So just as in guizero, we establish an APP object, here we have to establish a sensor object because that object is necessary to talk to the simulator. So I'm not sure why it's not called simulator, why it's called sensor. Actually, I have an issue with that, but no one cares. So before I forget, I'm going to go to the terminal window at the bottom, and I'm going to run the program pps_GUI, which is something you've downloaded. If this does not happen when you get in here and do this, something is wrong with your setup, and you need to get it fixed now. So let me know if you type this and either it goes, huh, or this doesn't come up, or this comes up and crashes. Something's wrong. Usually what happens if it's wrong is this just doesn't come up. If this is not running, your program's not going to work. So first thing is to establish a sensor object. The name sensor is very arbitrary. Maybe I would even have called it simulator. Probably a better word. It is a better word. Once you establish a sensor object, then
I blame Chuck.
Good morning. Who did what?
He blames Chuck.
Oh, no, not fair. Check it. For those of you who are in Dover, you can check out Jason Silverstein, who's an IIT person. Jason is the original author of this. He was in the office next to mine in Willington when he was working on this, and he was under the gun to rewrite 3 courses with virtually no help. So some of these things Chuck inherited. Now, the fact that that was a bunch of years ago, fine.
Absolutely, but it's Chuck's fault.
Okay, that's fine. I don't know, whatever. But there's absolutely no reason that you can't rename it to something that you like. Now, you can't rename this because that's inside of the code. Actually, you could, because it's not so easy. No. So something I would blame on Chuck. We were told to set this thing up not as a virtual environment. If we had set it up as a virtual environment, it would be easy within our project to go in and find the code for pps_emu and modify this to be whatever we want. But we can't. But there's no reason that we couldn't go here and say refactor, rename, and say that a better name for that is simulator. Simulator. And as you notice, PyCharm will go through and rename all the occurrences, hit enter to get out of that mode. And now you can see that we have a choice with our simulator of .output and .input. That's the only choices we have. So everything here has to fit into that model. So it's either an output or input, or it's just plain text. So here's some plain text. Here's some output things called lights, some input things called buttons, and some input things that are 3 different sliders. Now, we can see in guizero, we can't see it here, sliders actually can be used for input or output. So normally I will take this as input, but I can, if I have direct access to the slider, direct the slider in my program to go wherever I want. So the only thing this program did is started with a list of lights. And I'm using the word list in English, not in Python. It's actually not a list. Hover over it and we can see it's a tuple. It's a tuple with 4 strings in it. And it tells you, PyCharm tells you what the strings are set to. Not coincidentally, these names match up with these, which are the names of these 4 lights. So if I want to turn a light on, what I'm going to do is I'm going to use these, or one of these four things to turn a light on. Well, I want to do that in a loop because I don't want to do it 4 times. So I'm going to set up a loop for light in lights. Very deliberately, I made this plural so I can make this singular. Don't have to, but it reads nicely. And now I can say in English, go through each light in the tuple lights, and for each light, establish a variable, which will be a string from this, and go ahead and output to that light the status on. So it's going to turn the light on, it's going to go to sleep for 1 second, and then it's going to turn the light off, and then it's going to repeat. So if we run this program, which we could do over here, we'll see over here, the lights appear to move down in a pattern. And since we said over here, while true, that happens forever. So while true is a long time, right? We need a way out of here. Notice down here, the program was initiated, but it's still running. Well, yeah, it is. You can see it running over here. So how do we get out of here? A couple of ways. We can hit the red stop button over here. Sometimes you have to do that twice. I don't know why. That's not having anything to do with the simulator. Oh, okay, I was about to misspeak. Stopping this does not stop your program. Remember, this is a freestanding program. We ran this program from a terminal prompt down here. So stopping this will not stop your program. The only way to stop your program is to hit the stop button. And when you do, you'll see you get a keyboard interrupt. Last time we discussed that it is 99.999% likely that when you interrupt the program, it will be sitting here in the sleep command, because this program doesn't take very long to execute, but it takes a long time to sleep, 1 second. All right, any questions about what we've done here? So let's go ahead and find the piece of paper that I was looking for. Let's set up a working folder for today. And of course, you can do the same thing. And it needs to be unique. So we might as well give it the date, 6 February. I give up 23. There we go. I guess I'll do it the way I should. I'm going to go back to my templates. And I'm going to take my physical simulator template and copy it. Then I'm going to put it, paste it into here. And I'm going to give it a new name. And the name will be Simulator Demo 2. Simulator Demo 2. And I'll open it in the editor. I'm also going to close this one just so I don't get confused. That's a bad thing to get confused about which program you're working on. This can, and actually I really like the idea of renaming that. So I'm going to take this out. I'm not going to use this. I'm going to call this Object Simulator because I kind of like that idea. And I need to tell you what it is that we're going to do. Because if not, we're starting down the road with without a plan. So if you embrace the idea that a header is a good thing and a lack of a header is a bad thing that you'll lose points for, use this header to provide some description about what's going on. And what we're going to do today is we're going to make a car radiator warning indicator. Okay. So Who can tell me anything about how the radiator works in your car? And what can go wrong?
Bueller.
Say again?
All right, so the radiator circulates fluid in order to dissipate heat generated by the engine.
Right. Is it water that it's circulating?
I mean, in a pinch, you can use water, but that's not the most efficient medium to use to transmit heat.
Yeah,
Typically, use coolant.
it should be coolant, and water will kind of work okay, but not so much when the temperature goes under 32.
Right.
Because then the water will freeze, causing damage and not
Yeah.
circulating. So we expect that the coolant, before you turn your car on, is going to be at whatever the ambient temperature is. And we can expect that the coolant is going to heat up as it does its job of removing heat from the engine. And what could possibly go wrong? Why do we need a warning indicator?
I mean, if you have a leak, then you're losing coolant, which means that your engine's going to run the risk of overheating.
Certainly,
If
Yeah.
you've got improper material or an improper media in the radiator, i.e. water, it can expand and crack the radiator or just not circulate, which builds pressure and causes a slew of further headaches down the line.
yeah. The other possibility is that, again, especially if the coolant isn't doing what it should be doing, that this thing can overheat. And in which case your water, for instance, would turn into steam, and steam doesn't work well in removing heat. Water does. So basically, we need an indicator. And this is what we're going to do. We can't put in good numbers for this because we can't control the scale. The best we could do is we could say, let's consider this to be degrees centigrade. And then this would make sense. So later today, when we do the guizero version, we'll set the scale and we'll put some realistic numbers in. So here we're just going to make stuff up. And what do we want to do? If the temperature is less than 100, we want to turn all lights off. This is going to have three ranges: an off range, a good range, temperature between 100 and 140. That's the good range. So the green light will be on, and the temperature over 140, the red light will be on. So we're not going to use the other lights. It's either going to be red, green, or nothing. And that's what we're going to do. So I think that making those comments in the header is the right way to start a program. Now I have a plan. And what I need to do with this plan is I need to create an analogy. I need to make my shopping list go to Home Depot. What do I need for this project? Well, I need to know how to read the temperature. That's an important tool. We haven't done that before.
Go
ahead.
The Wi-Fi, I'll smack the shit out of you.
Uh-oh.
He's talking to someone.
Oh, Ben,
Oh, sorry.
who you smack what out of on your own time is your own business. Lost my train of thought. The simulator. Yeah, everything having to do with this physical simulator is described in a cheat sheet in D2L. So there's not that much to do with it. That sheet is your resource. So I know I need the temperature, a way of reading temperature, and it's going to be a simulated reading. Well, how do I simulate the reading? I come over here, I look at temperature, I find this thing, and I drag this thing to the bottom and to the top. Now, this is a poor range for radiator coolant temperatures, but it's a good range for outside temperature. But I can't do anything about that. So we will deal with that later. When I look at these three lines, I see that I have to make some decisions. And I would say the two critical things in programming, after you get away from variables and lists and such, is the ability to iterate, to loop, and the ability to make decisions. So we're kind of hinting into the next section in D2L, which happens to be called conditional structures. If we're going to pull this program off, we have to know enough about conditional structures as a tool to make it happen. I think we can. But we need to recognize there are three things that need to be accounted for. One is what to do with the temperature less than 100. The other is what to do between 100 and 140. And the other is what to do over 140. So we do need to be careful in this program of what to do at the border. So this suggests that 100 and 140 are the limits. They're inclusive. The low limit is less than 100 and the high limit is over 140. So that comes into how we build our decision structure, which we will do in a minute. But before we do that, now that we have a simulator object, we absolutely positively need to read that slider. When? Well, forever. So if we decide to drive nonstop between Wilmington and San Francisco, then this program should run for the entire time. Maybe this program runs with the ignition key. It turns on when it sees the motor start, it turns off when you stop. Or for the new people in the audience, or people with new cars, the ignition button, which is sort of replaced the key. So next up, it occurs to me that I need a loop, and that loop is going to last relatively forever. We know how to do that. While true. While true is one of several program containers. And program containers always end in a colon, and what is in the container is determined by indentation. So in a loop, I need to establish what the temperature is. So let's just create a variable for it because we're probably going to use it a few times. The temperature equals, I'm going to use the simulator object, and it's an input. And what is the name of the input? Well, hint, hint, wink, wink, it's these three over here. So the name of this input is TEMP. I disagree with the name. It should, I don't know if that means temporary or temperature, but I don't have a choice. I have to use it. And now I have the temperature. And what am I going to do with this temperature? Not check. So I've got a handy variable already called temperature. And I might as well go down my list. Let's see, that's not the way I did it, but that's okay. All right, I take it back. I'm not going to go down my list in order. What I'm going to do is I'm going to handle this range first. And Python gives you a wonderful way of handling a range. So the range is between 100 and 140. And this is the way you write it in Python. 100 less than or equal to the temperature, which is also must be less than or equal to 140. If is another container, so I put a colon there. And maybe this is a case where I will put an inline comment. Normal range. Okay, so what do I want to do? What does it say to do? It says, well, if you're between 100 and 140 inclusively, where does the word inclusively translate to Python on line 22?
It's because you got it set as less than or equal to.
Less than or equal to in both places. So this means inclusive of 100, inclusive of 140. Now, that may not be that critical here, but it's not a bad thing to know. Okay, so what am I going to do? Well, I'm going to, it says the green light will be on. All right, I can do that. I can use simulator.output. Which output am I interested in? GLED. And what do I want to have happen with it? It's going to be on. Okay. And let's clean it up a little bit. Let's ask the question if we have a runnable program. I would say we do. It doesn't meet specs, but it does say, if you're within range, turn the green LED on. So let's give it a try and see what happens. Remember, I made the point last time that if you're running a new enough version of PyCharm, there's a setting here for current file where it just will run whatever tab is highlighted. A little more convenient than remembering to switch it. Okay, so let's start the program. Let's look over here. Let's look at this. Is this correct so far? Are we within that range? Somebody say no.
No.
No, we're not. What happens when we move up? Nothing. What happens when we get to 100? The green light goes on. So far, so good. What happens when we get above 140? Right? Yay. Good news? Not such good news. So we've written one condition, and that condition is being held. Well, what happens if we're under 140, under 100? Again, nothing. We haven't done those conditions yet. So, timeout for an important observation, a very important observation. And one of the first things I learned on the job. If you are running this program at home, and if you have variable speed fans in your computer, you might notice your fan is cranked up when the program runs. So we'll go over here, we'll look at Task Manager, and we'll see what's going on. And we will see that this lowly program is using 13% or so of the CPU. Well, that's not good. The lesson is, do not create an infinite loop without a delay, because it will take up every available CPU cycle that it can find. It's bad news. Well, what are we going to do? What we're going to do is we're going to put in a nominal delay, where any old place in the loop, but make sure it gets executed every time the loop runs. So now we're going to use time.sleep, and we're only going to sleep for 0.1 second. We'll put an inline comment, small delay in infinite loop. And when we run the program again, it works the same, but my fan is not making noise. And when I go to Task Manager, I can see that it doesn't even make it into the top list. It's over here. Well, I can alphabetize it. But anyway, this program, the same logic is now taking no measurable CPU because it goes to sleep for 1/10 of a second every time it goes through here. I can't quite say that's important for this class, but I will say it's excellent style. So you might as well learn it now. If you need to create an infinite loop, then you need to have a sleep in that loop, someplace where it always gets executed. And that's what I learned when I was 21. So I used to say that's when I learned when I started my first job when dinosaurs were still roaming the earth. But nobody ever laughed, so I stopped saying it, figuring maybe they believed me. All right. So what's next? Well, we got to deal with some other conditions. Let's deal with an over temperature condition because that's important. Now, another critical question, and we'll talk more about this when we look at these loops in more detail in a week or maybe on Wednesday. Can the temperature be in normal range and overheated at the same time? Is that reasonable? Can it be normal and overheated?
No.
No. In other words, those two concepts are mutually exclusive. We don't need to run another if, because if it's within range, we be done and the green light is on. So we don't want another if statement. We want an elif statement. And elif is Python speak for else if. Well, now what are we testing? We're testing if the temperature is greater than 140. Well, we've already covered 140 exactly. That's the first thing. This is overheated. Overheated. Okay. What are we going to do if it's overheated? Well, we're going to get our simulator and we're going to output the R LED and we're going to turn it on. And we've covered the two cases. There's still one more to cover. Visually, maybe I want to put a blank line in here to kind of separate these two, make it a little easier to read. Okay, so if we were a face-to-face class, I'd be willing to offer a buck to somebody who tells me what's wrong with this program.
So the problem with it is that the green light's going to stay on regardless once it
Yeah.
exceeds that range.
Green light goes on, but it never goes off. And for
Yeah,
those go ahead.
I noticed that when I started running it because
Right.
I've got 4 different conditionals set up
Yeah.
to try and deal with that.
And for those of you who are, oh, what's the show me state, Missouri or something? For those of you who need to see it, let's look. Green light comes on, cool. Over range, the red light comes on, cool, but the green light doesn't go off. Now, when we go down, none of them go off. Well, let's be serious about this. You'll agree that Python and the simulator don't know diddly about car radiators. So everything that we have to say about a car radiator indicator has to be in the code. If it's not in the code, it's not happening. And what's not happening is the green and red light never get shut off. Well, that's because this is a simplification. Not only does the green light go on, but the red light goes off. R LED must go off. And you don't have to be too bright, which I'm not, to figure out that if that's true, then here the green LED has to go off. So what I like when I write a program is I like to look for symmetry. Does this look reasonable? Have I handled the two cases? Well, yeah. If I'm in normal range, I really didn't think it through, did I? Not only does the green light have to go on, but the red light has to go off. Well, now that I've tackled that, Now I know that if I'm overheated, the red light, not only does the red light have to go on, the green light has to go off. Okay. We got one more thing to do. Something weird happened here. Change to microphone. Somebody say, let me know if you can still hear me.
We can still hear you.
Oh, I'm getting messages about my microphone, blah, blah, blah. I don't know what it's complaining about. Cool. We'll move ahead. Okay, so the big question here, it's not a big question, but it's an important question. If it is not normal and not overheated, then it's warming up, right? That's the only possibilities, is that if we're less than 100, the engine's warming up and all the lights should be off. Well, there are no other possibilities other than normal, overheated, and off. And if it's not normal and it's not overheated, then it has to be off. So I'm not going to bother writing another test. I'm just going to say, okay, if it's not number 1 and it's not number 2, then it's just that. So the important lesson here, warming up. The important lesson here is that the else never has a condition after it. If must have a condition, elif must have a condition. Well, why? Because elif is really an abbreviation for else if. Else does not have a condition. And I'm getting lazy, so I'm just going to copy these lines. I'm going to put them here in the else container. I'm going to get my spacing correct. And I'm going to say that's my other condition. Warming up, both of them need to be off. Run the program. Warming up, warming up, warming up, warming up, warming up. Normal range. Overheated. Cooling back down. And now I shut the thing off. It goes black. So there you be. That's my simulator program. Any questions or things that you consider to be mysterious or dubious, or I'm trying to pull the wool over your eyes?
So a question.
Sure.
I started out by copy and pasting my conditional blocks. And is there a functional difference between using an if conditional versus the elif on that? Because I've got it working either way.
Yes. Yeah, there is. And it more has to do with efficiency than it has to do with right and wrong. If this succeeds, we be done, right? So if this succeeds, why go through another if? If this succeeds, we be done. Elif says, okay, if this doesn't succeed, then go ahead and do this. If this succeeds, we be done. If it doesn't succeed, go down to the else. So the way of writing this is if, elif, 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 else. That's the full implementation of if, elif, else. If you write if, you still need to handle warming up. And even if you didn't, then you'd be doing twice the work with 2 ifs. So the idea of elif is only do this if everything above failed. And that's why you have multiple elifs. So it has a lot to do with style. And in some cases, if you write multiple ifs related to the same thing, then weird things can happen. Because we know that these 3 things, normal, overheated, and warming up, are all mutually exclusive. It's got to be one. And that's why we don't bother doing an elif down here. There's no need to. If it ain't number 1, it ain't number 2, it's number 3. Okay. And that's something that's seems to be a difficult learning topic. How to use ifs and elifs and elses in harmony with each other. And not just say that elif is too confusing, so I'm not going to use it. That's the coward's way out. Not casting aspersions. No, I mean, you need to be comfortable with that. Now we should take a look when we do the conditionals at a new conditional. And darn, because they used a different word in Python that they did in Java, I keep on getting it confused. But in Java, it's called a switch statement. And it's kind of a multi-way branch, but without using if and elif. And Python now supports it. And it's either called match or something else. I believe it's called match. But we'll look at it. Okay, let's take a breath. It's a little early for a break, but we'll just take a breath. And it's not in that pile of paper because it's in this pile of paper.
We need that.
And I guess, I think I'm going to change my mind. I think we are going to take a breath because it's going to take a little longer to do this than we have to spend before everybody gets tired. So let me make a comment in general. And the comment is, we have plenty of Zoom time. We have more than enough Zoom time to cover this class. If you look on the course schedule, there's a bunch of blank time at the end, which is not going to be blank. We're going to use some, if not all of it. And we're ahead of our schedule, published schedule, by about a week. So what does this mean? This means that if there's something that's bothering you, or something about a homework exercise, or something in D2L, just something that doesn't sit right, or something I've said that sounds like gobbledygook, we got plenty of time to go over it. So don't let me keep going at full speed when you want to slow down or go back and review something. You're not going to use up the time. So that's my pitch. The other part of that same pitch is I've proven over many years of teaching that I can talk longer than you can listen. There's no point to you in letting that happen. So it's your responsibility. Face-to-face, it's a little easier. Literally or figuratively, people can put their head down on the desk when they've had enough, and I'll take a hint. Or start yawning or start looking at their watch. On Zoom, hard to pick it up. So just remember that we have all the Zoom time we need and then some. So feel free to do that. So that's why I've kind of decided that less is more. We're going to get ready to redo this in guizero, but we're going to do it after the break. So let's get ready. Let's go down to our guizero template and let's copy it because that's what we do with templates. Let's go into our, where did I put this? I'll find it. Oh, I see. No, I don't. I put this in the wrong place. Well, no big deal. I'll pick it up from here and I'll put it into here. And it says, do you want to move this? Yes, I do. And now things are better. So can I still paste the template? I can. And we will call this, we called that simulator demo 2. We'll call this GUI demo 2. We'll close this so we don't get confused. and we'll start working on this later. These things just structurally look different than simulator programs. The one thing that is very, very important that's different is that thou shalt not import time. This will ruin your guizero day. So that's off the table as a tool. We need to find another way of doing the same thing. We create an APP object that gives us an environment to work in as opposed to connecting to something external. So this goes away. And then in that object, we are going to build some widgets. Now, when we get to the end, we are going to call app.display. Oh, this thing is still running. We're going to call app.display, and in guizero, that is the loop that sort of replaces while true. So there is a loop here, but you're not doing the loop in here. Don't do while true in guizero programs. All right, so I blabbed for a little longer than I was planning on. Let's just get back at 10 o'clock and we will tackle this program. And I think that's all we'll do for today. I think it makes more sense to leave my other demo things, the counters and the accumulators, to next time. All right, so I will resume. Share. And before you are screen sharing, well, thank you very much for that information. Before we move on, questions about this program? So this is very typical of how we deal with the physical simulator. We figure out, you know, what are my inputs? Well, the only input is going to be this. What are my outputs? There's just going to be two of them, really, the green LED and the red LED. So I'm ignoring the rest of them. And now I need to know that what I'm trying to handle here is a three-way conditional. If I'm in the normal range, do something. If not, am I overheated? And if I'm not normal and I'm not overheated, then I'm warming up. So everything is attended to. This concept is going to move over nicely to guizero, the way of creating display, not so much. So questions before we move on? Now, I kind of like this header, so I'm just going to pick it up. So this is an interesting technique that works. If you click on the line number, not to the right of it, but right on the line number, you can highlight multiple lines and then do your copy. And we're going to go over here and we can paste that in right here. Close the simulator one. And now we just have to say, okay, what's different here? Well, what's going to be different, maybe we'll note here that we're doing a guizero program. What we'll note here is that these ranges are don't make a lot of sense, particularly this one. So let's say that the normal range is going to be 0 to 200. It's okay for the coolant to get hot. It's just not okay to go over boiling. Okay. And I still have a green check mark, so life is relatively good. I'm executing the current file, which is convenient. If I run this, I will get no errors. The program is still running, but that's all I got, right? Where's my graphics? Well, I got to do it myself. I got to create the GUI myself. And that's typically what you do first. Well, the first job is to figure out what you're doing. Maybe document it up here in a header. The next job is to create a layout. That can take a while. The more you do it in guizero, the easier the doing layouts will become, and you'll pick up some tricks. But it's a job that has to be done, because if not, you're just looking at an empty square. So one of the things that I typically want to do is I want to set my text size for the whole application to something bigger than the default, and 16 or 18 for smaller stuff, 20, 22, 24 for bigger stuff. And I've decided that, I guess I'll do that now. Notice that the title of this window is guizero, that's kind of sparse. So let's pretty it up a little bit and give it a nice title. So eventually you'll memorize these choices. If not, hover over this and you'll see the choices spelled out for you. Gotta move this down a little for me at least. So hovering, you'll see the choices. We have title, width, height, layout, background, and whether it's visible or not. Now, as long as you're using the equals, you don't have to specify all of them, and you don't have to specify them in order. So this is going to be the engine coolant temperature simulator. So what's being simulated is the alarm action. And let's put a background on. And this background will look a lot like the same background that we used in the other simulator. Okay. And now I decided that I would like to have a title. So this title is just in the bar over here. I want a title right over here and some big text. So how would I do that? Well, I either know, or I'd look up that there's a text widget. The widget, why is it getting dark in here? Hold on a minute. Okay. The widget needs to know where to go. And the only place to put it is an APP. If you're a text widget, you probably need some text. And the text could be whatever you wanted, like radiator, temperature, indicator, light. So now I have a nice title over here. I suggest what would be nice next would be to build a light. Well, that's going to be built with a waffle. There are other ways of doing it, but waffle is probably the most convenient. And in here now, I pop up a whole bunch of things that can be set. So waffles, you need to determine a lot of things. First thing you must do is you must, not optional, must tell it where to put it. Well, let's put it in APP. Then let's tell it how many, you must tell it rows and columns, which they call width and height, except it's not pixels, it's cells. So I want to create a waffle that is one cell high and one cell wide. I want the size of those cells to be bigger than normal. I want to put some, or the cell, I want to put some padding around it to get some space so things aren't squished. I want it to be a light, so dotty is going to be true. And now I can have an initial color. Wrong. Color of black. At any old time I want, I can go, don't have to do that now. Anytime I want, I can go back and see how my layout's coming. Not bad. I've got a little bit of space. I've got a big enough circle, and the circle is black. So far, so good. All right. What about the slider that I'm going to use for simulation? Well, clearly I don't have one. So clearly I need to build one. So I need a slider. Where do I put it? Well, I put it in APP. Now here's another long list. So there's a lot to be said about sliders. Particularly, what's the minimum and maximum value? Well, the default is 0 and 100. I'm going to keep the starting value the same. I'm going to set the ending value to 250 because that gives me some room. I would like this thing to be horizontal because I think it's going to fit better. And this again is the default, but I'll put it in there just to show it to you. And that's all I'm going to do for the time being. So how's my layout looking? Well, there's two things when you do these GUI layouts, and it's called UI, UX. UI stands for user interface. That means, does this thing have the tools it needs to be functional? And the answer is yes. User experience boils down to, is it but ugly? Could its appearance be improved? And the answer is yes. Why would I have a slider that goes from 0 to 250, but take up so little room? I want this thing to be wider. The other is, why do I have all this blank space in APP? What I really want is something more like that. So let's tackle those. So in APP, I would like a height of a mere 300. And I happen to know that the width is not bad and it does default to 500, but I'll put that in there. So once your line gets a little long, just go back to a comma, hit enter, and you can break it up. Okay, what was the other problem I was going to solve? The slider. The slider needs to be much wider. Now, I have 500 pixels in my window. So if I make this 400, that's going to fill it up. And I've decided that a height of 50 is appropriate. Remember, something weird happens here. Just shout out and tell me what you think weird has happened that's weird. So my user experience has been improved. This is now bigger. I can resolve things easier. And my margins, my overall window is fine. Okay. So at this point, I would say that my layout is done. One of the advantages, of course, of the physical simulator is that you get the layout. You don't have to build it. The disadvantage is it has no flexibility. So, there's pluses and minuses. Well, what's missing here is the action. GUI programs are referred to as event-driven programming, or event-driven programs. Something has to drive this. Something has to say, something has changed and you, Mr. Program, need to know about it. Well, considering that there's text over here and a circle over here and a slider over here, the only thing that could possibly initiate action is somebody changes the position of the slider. Now, you could write a program where you click on the indicator to do something, but that's not for today. So this needs an action or an event handler or a callback function. All of those words kind of mean the same thing. But none of them has to do with the word that guizero uses. The word that guizero uses is command. I must tell it the name of a function to execute when there is a change in the slider. And I'm going to make up a name of a function that doesn't exist called monitor. PyCharm says, hey, man, the function doesn't exist. Don't take the suggestion. The suggestion here is not really helpful. So let's talk fancy Python talk. This registers the function name monitor as the event handler for changing the slider. It's our function. Who's going to call this function? Well, guizero is going to call this function because we don't call it directly from our user interface. guizero does. Does that mean that guizero is going to watch this program execute to know whether there's an event? Yes, it is. That's what this is for. app.display says not only should you display the app window, but monitor for events. And if there is an event, anything that has a command equals needs to be run if that type of event happens. Okay, so what are we going to do? Well, we're going to write an event handler right now, and we're going to call it monitor. And since we're defining a function, we must have parentheses, and we must have a colon, and we must have an indentation. Okay. Okay, let me just look at something here. Yes. Let's print the word pass in here. Oh, no, let's not do that. Let's put a print in here. So event handlers get triggered. I still have a green check mark. This is no longer red. And let's see what new is going on. So I'm going to come here and I'm going to change this thing. And what happens over here? It says the monitor has been triggered. Now I could click over here and it'll change one at a time. So 28, 29, let's clear this out. Every time I click, I trigger that. Okay, so now I know that there's an event handler called monitor, and monitor, because it's the right side of a command equals, will run every time I hit this. And it prints triggered. Well, cool, fine. But how am I supposed to find out what the value of the slider is? That's kind of very important information, isn't it? You think that guizero has that information. guizero must know where the slider is, and it will be more than happy to tell you. As a matter of fact, that's usually the way this is used. If you provide a variable over here called anything, but I'm going to call it temperature, I'm not going to call it temp, and I print it over here, I'm back to a green check mark. And every time I change this, automagically, I get a value for this variable that I can then print. So that's pretty exciting. That means that whenever the slider is changed, I know what the reading is. And I've also, by calling it temperature, made the association that this represents temperature. And it represents temperature in degrees Fahrenheit. Okay, so let's give it a try and see if we can make this happen. If temperature is less than 100, if temperature is less than 100, what do I want to do? Well, I got a light over here, don't I? I want to turn this, well, in this case, I want to turn it black, but it already is black. But I need to put that in the code. I need to turn this black, and I have a big problem. My problem is that the thing that made the circle has no name. In other words, it's anonymous. Well, turns out this is anonymous. This is anonymous. This is anonymous. The only thing that's not anonymous is APP. So this isn't going to fly. It needs a name. And I like naming these things with 3 characters telling you what type of widget it is and then what's its function. Well, it's an indicator. So now my waffle is no longer anonymous. It has a name. Could have called it George, but I decided to call it WAF_indicator. And now when I refer to, and notice it's gray, no one's using it. Now when I start typing WA, PyCharm finds it. I can double click it. I can change its property, which is color, and I can make it equal to black. So that was so much fun. Let's do it again. And let's follow the same idea that we did before. We're going to write an elif. The temperature must be greater than equal to 100. And less than equal to 200. This is normal. This is warming up. This line we can copy. Put it over here. Oh no, Mr. Bill. What did I do? This we can copy. Put it over here. If it's normal, then the light is going to be green. And, oh, geez. And just like before, if it's not warming up and it's not normal, the only other possibility is what? The only other possibility is it's overheated. So I deliberately wrote these in somewhat of a different order because the order doesn't matter. What matters is that you write these things to cover all the possibilities, no less, no more. So I still have if, else, but I put them in a different order just because I wanted to. All righty. So let's see how we're doing. So I'm going to go ahead and change this. And not so good, right? So whoever said that sliders are great because they're idiot proof? Did you ever hear anybody say that? Well, if you did, they weren't quite right. What happened over here, and we'll talk a lot more about this next time, is that Python threw an error. Was actually guizero that threw the error, but it was actually tkinter that threw the error. So when Python executed line 16 over here, it ran into trouble. But it ran into trouble because this was being executed from within guizero, which then executed a line in tkinter. So this is where the problem actually occurred, but this is where you could see what in your thing did it. So it tells us the line number, it tells us the line, and it says what went wrong. What went wrong is you can't support less than by comparing a string to an int. Okay, so looking at line 16, which is the string and which is the int? Come on, this is an easy question. All right, if you don't ask yourself these questions, you're going to have a tough time getting your programs to work. PyCharm and Python are trying to help you. They say you can't do a less than by comparing a string and an int. So on
Yeah,
line,
because the string doesn't have a value, therefore it can't be compared,
it doesn't have a numerical value.
or numerical value rather.
Yeah, but which of those two, there are two things on line 16 being compared. Which is the string and which is the int?
Well, the integer is 100 and the string is temperature.
Well, why is the temperature, and I agree with you, why is temperature a string if it comes off of the position of the slider?
That I'm not sure.
And it's a trick question. The classical answer I heard to these questions are because God made it that way. Somehow in their infinite wisdom, probably TK Enter decided that when it provides this variable to make the variable a string. Seems like a really bad decision, but that's the way it is. So I don't want a string, I want an integer. So I will, and this may look freaky at first, but I promise it works. Int temperature. Okay, so I still have a green check mark. There's no objection from Python in doing this. Does anybody want to either explain what's going on here or guess what's going on here? Why does this not complain? Okay, so what is it? Clearly, it's an assignment statement. And what did we learn about assignment statements? We learned that you do everything you can do on the right side of the equal sign. Well, that says take temperature and try to convert it to an integer. Then assign whatever you got to the variable or variables on the left of the equal sign. So Python probably, well, it's not the only language, but is very different than Java in that let's hover over this and see what it says. It doesn't know what type this is. Does it know what type this is? No, it doesn't. Does it know what type this is? Not yet. So let's get some help here. There's a command, built-in command called type. And we are going to type, we're going to have it print what type of variable temperature is. And once you understand this, then a lot in Python becomes more obvious. So check it out. Here in line 16, the variable temperature is a string. Well, we knew that. That's why I got the error. Once we do line 17, when we print it again, the type of variable that temperature is has mysteriously changed from a string to an int. And that is a Python way of dealing with things. Some people love it, some people hate it. It's an invitation to screw things up if you lose track of what's going on. The simple way of saying it is that temperature has been cast from a string to an integer. And it will support it by doing that. Now that I know that, I don't need this. I don't need this. Okay, so now we believe that this variable has now been transformed into an integer, and we're hoping that no errors occur. No errors. So this is warming up to 100. At 100, it turns green, and it's okay until it gets to 200. At which point, after 200, it turns red. Well, what about shutting off the red? Well, for a waffle, it's a stupid question. There is only one cell whose color is red. So when I go under that range, the color becomes green. When I go over here, the color becomes black. So we don't have 3 indicators. We only have 1, and we can change the color property. That's not something that you have available in the simulator. You can't change the color property. The property is either the thing is on or off. So there we are. And where are we? There we are. And this, aside from the ranges being a little different and a little more reasonable, this is the equivalent of the simulator demo, right? All this if else really just gets done a little differently. Well, what's different? What's different here is I have to build my own layout. And I have to tell it to go into a loop with app.display. So there's no way around it. If you're doing guizero, you have to build the layout. Now, instead of hokey while true and nominal sleeps, you turn it over to app display, and this handles this, monitoring. So that's kind of magic behind your back. Command equals is one of 2 or 3 different ways of setting up event handlers, and we'll do others later on. So, questions about what's going on in here? The things you want to hear more about or hear again about? Comments about whether, is this much harder than this? You know, which would you say you would use this program because it's easier? Or would you say you would use this program because it's more flexible and not much harder?
I think the only really added difficulty in this current program, the one that we just made, that was that we had to design the GUI ourselves. The other one was already made for us. So the really, what looks to be the most complicated part is creating the GUI.
Right. And the advantage, the good news is that the more you do it, the easier it becomes.
Mm-hmm.
The disadvantage is the more complicated the GUI, the more lines of code it's going to take.
Right.
But creating the layout is rather mechanical.
Mm-hmm.
The difficulty is in the logic. And this might be a good time to talk about something that they used to refer to GUI programming. They call it MVC, and that stands for Model View Controller. Well, what in the world does that mean? The model is your data and the rules to manipulate it. So where is the model? The model is basically here.
Mm-hmm.
The view is what you look at. Well, this is what you look at. And the controller is what ties them together. And that is the monitor function, is what connects the view and the model. When you do this in Java, the ideas get split up into different files. So for those of you taking programming 2, you'll see this in Java FX, where it appears a little different, but the concepts are the same. So model, it's the darn same model. Here's the model. Here's the model. There's no difference other than how we make those actions.
Right.
So yeah, these actions are actually easier. And of course, now that I have to create the layout, I can create whatever I want.
Mm-hmm.
So I don't need 4 lights. I could have had 2 lights, a red and a green, but that would be a little stupid. So we won't do that.
I see the biggest advantage here is by doing the user interface yourself. It gives you ultimate flexibility as far as how complex or how simplistic you want the program to actually be.
Absolutely true. And it also gives you your choice of aesthetics. So you can balance layouts and colors and stuff like that. And this is extremely simplistic. Now, remember that the physical simulator is a guizero program. So that's what somebody did. They laid it out between Jason and Chuck. Actually, Jason laid it out the first time and Chuck redid it. So that simulator, now you can go back with a new appreciation of what you're looking at. And notice essentially the same background color. And notice this is divided into some sections. And here are the sliders down here with some stuff over here.
I'm definitely gonna have to dig more into the guizero documentation, because that first thing I tried was to set some of the colors using hex values, and it doesn't like that.
Oh, it does. You just have to do it right. Yeah, dig through the guizero tutorial. I guess what I remember is that they're, I'm not proud, I'll try. Okay, so we want to change the color of the background. Pretty sure it has to be a string. I'm pretty sure it has to have a pound sign. And let's make it gray, which would kind of be 6 or 7 is about in the middle. So red, green, blue. What do I win? Okay. So you can express it as numbers, but if you're going to do it this way, they have to be hex. Well, the whole thing has to be a string. And in the string has to be a hex designation, hence the pound sign. And then there are 2 hex digits for red, green, blue. So if I wanted something lighter, I would go like AA, AA, AA. And that should be a lighter shade of gray, which is not unattractive. I want to mix it up and throw some stuff into it. Now I could do AA 77 AA. And now I get Grapple. Okay, so yeah, you can mix your own colors using this. All covered in the guizero documentation. So yeah, the strength I see here is obviously flexibility. I also think that the strength here is that you understand what these elements do. You're not using the simulator code to kind of hide things from you. So, you understand that you must specify event handlers to do what you want to do. You should understand that the widgets that you build may either be named widgets or anonymous widgets. They only have to be named if you need to name them. So that kind of makes things a little clearer also. And of course, ultimately, using guizero, you can design whatever can be done within guizero. If you really run against a wall that you can't do it in guizero, you might be able to do it in tk-enter, which is what guizero uses. tk-enter does more things, but it's harder to use. Now, there's information in the guizero tutorial about how to combine the two, and they combine very nicely. If you don't like that, you can go to Turtle, which is really different. And if you don't like that, you can go to Pygame. That's also different. And there are other guizero-ish things that you can use. So there's no shortage of these GUI languages in Python. Jason and I both like guizero, which I think Jason discovered, because of its simplicity. That's what the 0 was supposed to imply. Here's the simplest way of getting you into a GUI environment. Also something that can be taught at the beginning of the introductory class, not at the end. So if you do tk-enter, it really has to go at the end because it's so complex. All right, any questions on what's going on here? So we have a little time. Let's just try something else with this. And that's the fact that we're guessing that somebody can figure out what red and green means, but maybe they can't. So let's add some text over here. Under the light and above the slider. Under the light and above the slider. Well, that would be over here. And that kind of gives you a clue that right now, because we don't know any better, when we put widgets into APP, they go in top to bottom and horizontally centered. Ultimately, that's going to be annoying, and we're going to learn how to be more flexible. So this is going to be a text widget, but we're going to have to give it a name. Text status. And it's going to be a text widget. And it's going in APP. And that's about all I want to say. I don't want to say anything else. And things got moved down a little bit here. I think we're okay, but we'll find out. Okay. If I didn't say anything else, well, I mean, I can take a peek. Text equals okay. I can take a peek and I can put something in there for right now. But I don't really want to. I want the text in that widget to be event-driven. So I'm going back here and I'm going to say, I want to do something else other than make the color black. What do I want to do? Well, I want to refer to a text widget, but I forgot what name I gave it. So I'm just going to type TXT. PyCharm will find it and I can just double click it. Well, I don't want to change the widget. I want to change the value of the widget. To what? To a string called warming up. Maybe some blank lines here. Oops. And if this was a good idea, then I can do this. And this is in the wrong place. So I'll take this out of here, put it over here. This is normal. This is overheated. And PyCharm is, look, got your back. PyCharm is trying to do spell checking. So if I misspell it, I get an indicator. If I hover, it'll make a guess about what it should have been and correct it. The newer versions of PyCharm will also attempt to do grammar checking. So sometimes you will see grammar come up as an issue. So what do we have? We got nothing. So this is the engine being off. When the engine comes on, we can see we're warming up. Now it's normal. Now it's overheated. Well, we might as well get some color clues, right? Let's get some color clues in there. So this TXT widget is going to have a color or a text color of black. Try again. See. This is going to have a text color of green. And this is going to have a text color of red. And this has too many blank lines. So we'll let PyCharm fix it. And this, okay, that's better. Okay. So there's my text that now changes color. So the crucial thing to learn about widgets is that once you create them, they have properties like their color, their value, their size, and they have functions that you can perform with the widgets. And that's a little more sophisticated. So in the few minutes remaining, let me make a user experience comment that the slider and that new text field are kind of scrunched together. So I'd like to get some space. Well, two things. I need this window to be higher. Actually, let's do it the easy way. I need the window to be higher. Well, easy peasy. I go here and I make this 350, and now I have some space. But what I wanted is I want the space up here. So I need to push the slider down. Well, how am I going to push the slider down? Fortunately, there's a widget called Box, and it goes in APP. And if you're a box, you have to have a height. Well, the height is the number of pixels to move it. And I must have a width, although quite frankly, I don't care what the width is. And just for the time being, I'm going to show you the box by giving it a border. So there's the box, but I really don't want to see it, do I? But I do want it there, and I do want it taking up space. So there you go. So I can use a box widget to take up space invisibly. Now, when I was young and stupid, I figured you could do the same thing with a text widget. It turns out it's a bad idea. Box widgets are the way to go. Also, I discovered early on that in guizero, you could lay things out in a grid in rows and columns. And then it turned out to be a pain in the neck, especially when things got complicated. So boxes are another layout technique that we'll learn how to use later. So boxes are a valid container. Just like APP is a container, the box is a container. Now, since the box is anonymous, we can't put anything in it. But if we want to put things in boxes, like other boxes, we can. As a matter of fact, within the box or APP, we can also say whether we want to align to the top, bottom, left, right. There is no center align, but there is that. And I can illustrate that very quickly over here, saying I would like to align this to the bottom. To the bottom of what? To the bottom of its parent. Who is the parent? APP. Okay. Well, it is aligned to the bottom, and you can tell because if I move this, the slider moves. The problem is I need a space underneath this. Well, I could cheat, copy this. Oh, and put it where? Good question. The first thing I want to put in is this box. But this box, I want to align to the bottom. And I'm kind of winging it and hoping for the best here. Okay. I probably want a little more space there. So what I'm saying is layouts are kind of, you go around until you've decided that you've had enough and you stop. I guess we made the thing 50 units higher. And if I want to see it, just put a 1 in there. And there's the spacer on the bottom. And now things are balanced and I don't want to see it anymore. So there you go. So your layout, multiple things changing, the event handler being used to track the track the cursor. It's a little weirder than I've led you to believe. Notice this slider is anonymous. You get to the slider by, or you use the slider by having command equals. If you give the slider a name and you refer to that slider's name by with a dot value, you will get an integer, which to me is just freaky, but that's the way it is. We'll look at that later on in some other thing. All right, so I've managed to use up my time. Questions about what we've done here? You know, we spent the last few minutes trying to make this layout prettier and better. All right, we're good? Okay, so let's, when did I, okay.